On a clear summer morning in 1996, two airliners entered the same patch of sky over India. Air traffic control had given them separate altitudes, but a miscommunication left both at the same level. The collision that followed killed 349 people and shattered the belief that ATC alone could keep the skies safe. But there is a last line of defense, a system that works independently of ground control. It's called TCAS, the Traffic Collision Avoidance System. Every few seconds, it pings the transponders of nearby aircraft, building a picture of the sky that no human controller can see. When a threat is detected, TCAS issues a resolution advisory, a direct command to climb or descend. And here's the rule. RTTI. Pilots must follow that command immediately, even if it contradicts air traffic control. TCAS is the ultimate authority in the cockpit. So how does a machine in one cockpit see another aircraft miles away through clouds and darkness? The answer lies in a silent conversation, a rapid-fire exchange of radio pulses, invisible to human senses, but carrying life or death information. Each TCAS-equipped aircraft broadcasts an interrogation on 1030 MHz. Nearby transponders reply on 1090 MHz, revealing their altitude, range, and bearing. The system calculates the time until closest approach, and decides if a collision is imminent. When the computer judges that another aircraft is too close, typically within 40 seconds, it issues a traffic advisory. A chime sounds in the cockpit, and a yellow circle appears on the display marking the intruder. The crew must look, but not yet act. But if the threat continues to close, the system escalates. A red resolution advisory flashes. Climb, climb, or descend, descend. And the pilot must obey instantly, even if air traffic control says something different. This is the last line of defense. So when a collision threat appears, what does TCAS actually tell the pilots? The answer is a command so urgent, it overrides everything else in the cockpit, even instructions from ground controllers. A resolution advisory is a crisp, unambiguous directive. Climb, climb, or descend, descend. It appears on the pilot's primary flight display, accompanied by a synthesized voice. The system calculates the exact vertical speed needed to avoid collision, and pilots are trained to respond within 5 seconds. This precise guidance ensures the aircraft escapes the collision path. But here's the crucial detail. When two aircraft both have TCAS, the systems talk to each other. They coordinate their RAs so that one plane climbs and the other descends. This prevents both from making the same maneuver, which would be just as dangerous as doing nothing. This coordination is the system's genius, and it turns a potential catastrophe into a choreographed escape. The FAA puts it plainly. TCAS II provides coordinated resolution advisories to ensure that two aircraft do not maneuver in the same direction. But this system didn't always exist. Before the 1990s, pilots relied entirely on ground controllers to keep them apart. A single layer of protection that could, and did, fail. The question was, how many lives would be lost before the world learned that lesson? The answer came on November 12, 1996, over the village of Charki Dadri, India. A Saudi Arabian Airlines Boeing 747 and a Kazakhstan Airlines Ilyushin Il-76 collided in midair, killing all 349 people on board. The accident report concluded that a single layer of protection, ground control, was insufficient. In the aftermath, aviation authorities realized that a second, independent layer was essential. A system that didn't rely on ground controllers. That system was TCAS, already in development but not yet mandatory worldwide. The tragedy at Charki Dadri became the catalyst for change. So now when a resolution advisory sounds, pilots know they have a last line of defense, one born from the ashes of disaster. But here's the catch. This system only works if pilots trust it more than the human voices in their headsets. And sometimes they don't. The system works when both planes obey, but what happens when a pilot hesitates or follows the wrong voice? That question has a real, tragic answer. On the night of July 1st, 2002, a Tupolev Tu-154 and a Boeing 757 were on a collision course over southern Germany. TCAS issued a resolution advisory to both, one to climb, the other to descend. The controller, working alone and unaware of the TCAS RA, told the Tupolev to descend. The crew obeyed, overriding their cockpit warning. The Boeing, following its RA, also descended. Both planes turned toward each other. 72 people died in the fireball over Lake Constance. The lesson was brutal. When TCAS speaks, it must be the final authority. The myth that ATC alone can protect the sky ended here. So TCAS works brilliantly when every aircraft talks back. But what about planes that don't? General aviation aircraft, small Cessnas, Pipers, home-builts, often fly with no electronic voice at all, invisible to the system. In busy airspace near airports, a TCAS-equipped airliner may have no warning of a nearby Piper Cub until it's too late. The system's range, about 30 to 40 nautical miles, means nothing if the target never replies. Regulators have tried to close the gap, mandating transponders in controlled airspace. But thousands of vintage and experimental planes remain exempt. The sky still holds pockets of silence where TCAS cannot see. So TCAS is a silent guardian, watching the sky when human eyes and voices cannot. Today, over 90% of the world's commercial aircraft carry this invisible shield, a direct legacy of the disasters that proved ATC alone was never enough. The FAA states plainly, when a resolution advisory is issued, the pilot must follow it immediately, even if it conflicts with ATC instructions. This rule, hard-won from tragedy, is now drilled into every airline pilot on the planet. But the system is not perfect. In mixed airspace, a small plane without a transponder remains invisible, a blind spot that regulators continue to wrestle with. Thousands of exemptions still exist, leaving gaps in the safety net. But how do two TCAS units avoid giving contradictory commands? They exchange data through a dedicated link, agreeing on who climbs and who descends. This coordination happens in milliseconds, invisible to pilots. TCAS works beyond visual range, using radio pulses that travel at the speed of light. It can detect threats up to 40 nautical miles away, giving pilots time to react even in poor visibility. To avoid false alarms, TCAS ignores aircraft that are far above or below. It only tracks those within a vertical range of about 1,200 feet. This focus reduces clutter and keeps the system reliable. The system calculates tau, the time until closest approach. If tau drops below a threshold, it triggers an advisory. This time-based logic is more precise than simple distance, avoiding unnecessary alerts. But TCAS relies on transponders. Aircraft without them remain invisible. In remote areas, general aviation planes often fly without any electronic identification, creating blind spots in the safety net. Helicopters also pose a challenge. Many fly at low altitudes where TCAS is less effective, and some lack transponders entirely. In busy urban airspace, this gap can be critical. TCAS has evolved since its introduction. Version 7.1, now standard, includes improved logic for coordinated RAs and better handling of altitude reports. Each update makes the system more robust. Pilots train extensively for TCAS events. Simulators recreate collision scenarios, drilling the instinct to obey the RA instantly. This training has saved countless lives by overriding natural hesitation. After Charkhi Dadri, the International Civil Aviation Organization mandated TCAS for all aircraft over a certain weight. Today it's required in most controlled airspace, a global standard born from tragedy. So every day, thousands of aircraft silently coordinate their paths through the sky. TCAS is the invisible network that keeps them apart, a digital guardian watching over the crowded airways. But how do two TCAS units coordinate without confusion? They exchange a digital handshake through Mode S transponders, sharing their intent in milliseconds. This silent agreement ensures one climbs while the other descends, turning a potential disaster into a choreographed escape. So when does TCAS decide to act? The system uses a 40-second threshold for traffic advisories and 25 seconds for resolution advisories. This narrow window gives pilots just enough time to react, but not to second-guess the machine's command. Once an RA is issued, TCAS displays a vertical speed target on the pilot's flight director. The pilot must adjust the aircraft's climb or descent rate to match the green arc on the indicator. This precise guidance ensures the aircraft escapes the collision path. TCAS relies on accurate altitude data from each aircraft's altimeter. If a transponder reports incorrect altitude, the system may issue a false alert or miss a real threat. That's why altitude encoders are tested regularly to ensure the sky remains safe. But TCAS is evolving. The next generation, called ADS-B, broadcasts position via GPS instead of relying on radar-like pings. This gives pilots a more accurate picture of nearby traffic, reducing false alarms and extending coverage to aircraft without traditional transponders. And yet, for all its limitations, TCAS remains the ultimate safeguard, a technological patch over the frailties of human attention and communication. The sky is safer because of it, but the silence it guards is never